Everything we discussed yesterday, you've forgotten it so fast. Our lambda here is what? Is what? You are not bold while saying it. Are you not sure? Who is saying half of lambda? Please, by now you should understand these things very well. Bathsheba, our lambda here is what? Our lambda here is what? What did he say? He said what? Bathsheba, were you in class yesterday? Were you in class yesterday? The length of this wave is what? Our lambda here is what? L is equal to what here? I want somebody to tell me the answer from the back. If they see that I want to point them, they will remove their face. Yeah. Okay, you tell us. Our lambda here is what? Many of you are not reading your notes when you go to the house, right? Many of you are not reading your notes at home, right? Is what? Do you understand why it's 3 lambda over 4? Who is saying no? Be bold now. If you are saying no, be bold. You don't understand. Were you in class yesterday? You did not come yesterday. You came yesterday and you did not understand. And you are sitting at the front. Somebody needs to take your space here. Okay? By now you should know what is harmonics. Should I give you a little time to explain everything? Are you sure? Hello, by now you should know what is harmonics. What is harmonic? What is harmonic? What is an overtone? Okay, harmonics are a whole number. No, she's saying something now. She wants to define harmonics for me. Harmonics are what? Whole number multiples. Hello. For those of you that are not those that are not around yesterday, we say this one harmonic. This one harmonic. Toby, you are seeing it very well now. You are sitting at the front. This 2. Is that okay? And we say this is a wavelength. So every definition of L you are going to get, let it be based on this, on the understanding that you are having on this. Is that okay? Now, if we say this is 1, right? Half of this now will be what? From here to here. Is that okay? 1/4 of this now will be here. Do you understand? Yes. Who is saying no? Let me see you so that I can speak to your direction. Who is saying no? Now, I said this is one harmonic, and this harmonic is 2 successful quests, 2 successful drop, right? And that's the complete definition for a wavelength. We can say this is one wavelength, right? I'll just write it like this. I'll no need to write it one wavelength, because 1 multiplied by wavelength is still wavelength. Is that okay? So this thing, if you divide it into 4, if you divide this into 2, divide it into 2, right? It's just that it's as if we pick one of these and place it here. That's what we are having here. So it's 1 all over 4. Is that okay? And here we are having single one, right? Yes. Single harmonic is what? 1 all over 2. Is that okay? Plus half. Just like I say, 1 all over 2 plus 1 all over 4. What's the answer? Do you know how it's 3 over 4? And some persons will still be asking. If you are looking, you'll be saying 1 plus 1 is 2. Do LCM, simple arithmetic. Is that okay? Is that okay? Is there anybody that did not understand this? Okay, let's move forward. This, by the way, so do you understand it very well now? That means, do you understand it? Let's move forward. Where C is end of correction. Are you two drawing this? Figure A and B are first and second position of resonance. So the first okay. Are you two with this? Can we move forward? If you are attending morning class now and you are listening to music in the class, end of correction, end of correction, end of discussion. Can we move forward? Can we move forward? See, if you report that you are disturbing, I'll just send you out. The next time you make that report. And I promise you I'll do that. Can we move forward? Yes. Now, from this diagram, you notice there's something different. C. C is the distance between this open space and the, we are having L here. This is C. Right? Where C is end of correction. Don't forget, we're talking about measuring velocity of sound in air, right? So this correction must be applied to it, unlike the tube, unlike the open pipe and closed pipe. So it's with the value of this correction now, let's just say you are getting something between plus and minus. Is that okay? With this correction now, you'll be able to get an accurate value of what, or close to accurate value of what the velocity is going to be. Do you understand? Okay, like now, if you are solving in graph, like in physics, there are some questions they will give you. They say your answer should not be more than between 1.2 to 1.4. It means any graph you are plotting or anything you are getting outside this value is wrong. You understand? Because when some persons are getting 1.21, that person is getting 1.22. You know, when you are doing practical, there are some errors that will occur. They say when the stopwatch is on 30 seconds, stop it. Some persons may stop it at 30 seconds and some milliseconds. You understand? So it will not make them to have the same value. But plus and minus, at the end of the day, if that experiment is well performed, their value should not be more than this. It should be in this range. Is that okay? Now, we're talking about resonance tube, and we're talking about getting the velocity or frequency of sound in air. Is that okay? Unlike the normal tube that has an end, or the one that's not even having an end, but it has a length. I don't know if you get what I'm trying to say. Like if I'm having a pipe from this end to this end now, you know the length. You don't need anything, right? Either it's closed or open. Now, if we're talking about velocity of sound in air now, resonance tube, we say we use it to find the velocity of sound in air. How do you know the distance? How do you know if the length that is being given is the real length? That is what brings in this C, end of correction. So whichever value of air that you are getting, C is being added to it. Is that okay? C is being added to it. And then your first position of the resonance will be L1 plus C. Let this be L1 and let this be L2 to differentiate them. Be having L1 plus C to be equal to lambda all over 4. It's still the same thing we're doing since yesterday. The only difference we are having here is this end of correction. The one we saw previously, we say L is equal to what? Lambda all over 4. And we say lambda is equal to what? 4L. But in this case now, we're going to be working with C. And it's the same thing. We are making lambda subject of the formula. So our lambda will be equal to what? Lambda will be equal to what? Am I not having students in the class? Our lambda is equal to 4L1, right? Plus, you can decide to put this in bracket. Plus C. Why? The second will be, we're having what? L2 plus C is equal to what? 3 lambda over what? And our lambda will be equal to what? 3 lambda is equal to 4 L2 plus C, right? So our lambda is equal to what? Sorry. Is that okay? Take note. Any formula you are having, nowhere is applicable. They are talking about your position in the open pipe a closed pipe, resonance tube, they are all different. Vibrating strings. Now let's name this equation as equation 1 and this as equation 2. Can I wipe what we're having up here? Subtracting well, L2 plus C minus L1 plus C is equals to 3 lambda all over 4 minus lambda all over 4. Hello? Hello? Now subtracting 1 from 2, right? If I'm making use of this, removing this equation, L1 plus C is equals to lambda all over 4. We are minusing it from, subtracting it from this. We are having L2 plus LC minus L1 plus LC is equals to what? 3 lambda all over 4 minus lambda all over 4. Is that okay? So we'll be having what? L2 plus
L2 minus L1.
L2 minus
L1.
L1. We'll be having L2 minus L1 will be equal to what will be having here? 2 what?
2 lambda. So equals to 2 lambda over 4.
Is equals to 2 lambda over 4. Then our lambda will be equal to what? We'll be having 2 lambda is equals to 4 L2 minus L1. Right? So we'll be having lambda will be equals to what? 4 L2 minus L1 all over 2, right? It should be equals to what? 2 L2 minus L1. Is that okay? Now we are not true. Where we are having V is equals to what? V is equals to what? F what? V will now be equal to F open bracket. Sorry. F multiplied by 2 L2 minus L1. This will now be your velocity. Resonance 2. So V here is what? The velocity of sound in air. Right? V here is the velocity of sound in air. What's the time? Ola, what's the time? No. Okay, let's take few example and go to light. We are through with sound. What of the?
Yeah, that's what you want to know. No, you say let's do example first.
I've started doing it well. There was one question I saw in the textbook, JAMB, I think 1980 something. That question you use 1 minute or 2 minutes to solve. Can we move forward now? Example. A source of sound. Your mind should be rolling across all the formulas in sound now. Because the question may come from the end, it may come from the beginning. Is that okay? Is that okay?
Yes, sir. It's also sound.
A source of sound. Produce a wave in air of wavelength in air of wavelength of lambda. Just write lambda, just draw the sign. 1.65 meter. 5 meter. If the speed of sound in air is 330 meters per second, if the speed of sound in air is 330 meters per second, 330. 330. You've not asked somebody. Please, can you have not asked somebody, bros. Please, I beg, help me spell tell in exam. You know 5 plus 5 is 10, oh, but you still want to do with calculator so that I be sure. Okay, calculate the period of the vibration in seconds. Calculate the period of the vibration in seconds. So which formula are we using? 0.005 seconds. Eh? Is it? We're looking for the time. So, are you sure you have not solved this question before? Your base formula is what? V is equals to what? Right? This is where we started from. Your mind should be going through all those things. Your mind should be going through all those things. F is equals to what?
IT.
IT.
Well, sorry, 1 over T.
If you say F is equals to 1 over time, having V is equals to F lambda, right?
Yes.
It means when you say F is equals to 1 over T,
Yes, sir.
it means you are saying 1 over T multiplied by lambda, which will give you V is equals to what? Lambda over T.
Yes, sir.
So can you solve from here now? Let's say, by you listening to music, she will not even hear if she's listening to music. Are you solving?
Are you solving?
But you know your name, I'll be calling your name plenty time. That's how I'll be calling Toby, 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 Toby. What's your real name? Example 2. What are you solving here? What are you solving? I'm already giving you a formula. V is equals to lambda over T. Just divide and tell me the answer. You still want to solve. 5 exponential. 5 exponential minus 3. How many persons are having 5 exponential minus 3? You too. People are correct. You are correct. Can we move forward? Velocity of sound wave. The velocity of sound wave. Look at what I did on the board. Olaya still asking. I know the one that say F is 1 over T. Okay, 1 over T multiplied by lambda. 1 times lambda is what? You have lambda over T. So there's no. You are cross multiplying.
No, I was dividing.
Okay. Whichever thing you are doing, don't do that again. Velocity of sound wave at 27 degrees Celsius. Velocity of sound wave at 27 degrees Celsius. This is how to write 27 degrees Celsius. 27 degrees Celsius. Those of you that attended the same secondary school with me. 27 degrees Celsius is 360 meters per second. Calculate its velocity. 360 meters per second. Velocity of sound wave at 27 degrees Celsius is 360 meters per second. I'm still coming again so many times. Where did I come? Did I go to the former question? Velocity of sound wave at 27 degrees Celsius is 360 meters per second. Calculate its velocity at 127 degrees Celsius. Degree Celsius. Be writing question while some people are solving already. I should start afresh. You be writing question while some others are solving already. Velocity of sound wave at 27 degrees is 360 meters per second. Calculate its velocity at 127 degrees Celsius. The answer is 423. The answer is 423. Did you refresh your memory as to the formula that connects temperature and velocity? Did you? Yes. They have solved it before.
No, not exactly, but very, very close.
that one. That one can
Are we supposed to use it in Celsius or we have to convert it to Kelvin before using? Eh? So if you are converting it to Kelvin, it will be what? 27 plus what? Eh? Convert it to Kelvin. Don't use it in Celsius. What's the difference between Kelvin and Celsius? Eh? Somebody say 273. Unit of temperature is what?
No, I've already done that one. 100.
The answer is what? Do you know the formula to use? Go back to your notice there. Eh? The formula is in your notes. There was a place I said, if you are being given two velocity and two temperature, you'll be having V kaza kaza all over V is equals to root of theta all over root of theta. You can't remember? You remember? It's in your notes, unless you did not copy the notes.
Sir, please, the second degree is 137.
Second degree.
Yes, no, the second one. The second temperature is 127 or 137.
127. Oh, you can see the temperature. Ah.
That was 17.
Can we go to the next question? What's the answer for this? 240 root 3 is what? Root 3 is what? Root 3 is what? Multiply through what's the final answer? Multiply through what's the final answer?
415.7.
41.
415.7.
Allah, you got what? 413. You did not convert the. Where did you now reach? This is the correct answer. Do you got 240 root 3? You did not get 240 root 3. You solve directly with calculator. You're not fair now. You are close to the answer, but close to the answer is not the answer. 416. Why are we having different answers? 415.7 is correct. Now, did you get this? 240 root 3. How did you got 423? You have known the formula already and you know what to do. That's the most important thing. Because this is not the question JAMB is going to give you. And even if they want to repeat, they will change the value. I don't want to give you simple question. Something that you say V is equals to lambda times frequency. Everybody should know how to solve. But some persons will still be asking which formula are they going to use. Right? A plain sound wave of frequency. A plain sound wave of frequency 85.5 Hz. A plain sound wave, or you can write a sound wave. They're just trying to confuse you. Whether plain or vertical, a sound wave is sound wave. Don't allow the English to confuse you. A sound wave is sound wave. Of frequency 85.5 and velocity 85.5. The frequency. 85.5 and velocity 342 meters per second.
342
meter per second from a vertical wall. From a vertical wall. Full stop. At what distance? At what distance from the wall does the wave have an antinote? At what distance from the wall does the wave have an antinote? At what distance from the wall does the wave have an antinote? The question is talking about antinote. I'm supposed to find wavelength. We are looking for distance, so and distance is the wavelength. What are we going to use? You have antinote there. When you hear the word antinote, what comes to your mind? The length of antinote is what? Lambda over what? It's also the same as what? 1 all over 4. So what is the lambda? When you get your lambda, multiply by 1 all over 4. That's what they are saying.
This one is very easy now.
You get your lambda, multiply by 1 all over 4.
V equals to S lambda.
0.97. This is your calculation work. You will not solve manually, right? Do you understand the question? Antinote. One antinote is 1 all over 4, right? Then when you get your wavelength, multiply by the antinote. That side is 1. Just approximate your own. We are still approximately. Be approximating. V is equals to what? Right? V is equals to V is equals to what?
85.5.
Our lambda is equals to what? Lambda is equals to what?
342.
Right? V is what? 342. 3 point.
No, 340.
All over F is what? Was it 88 you use? The answer is what? 4. Are you sure?
So the answer is 1. The answer is 1 apparently.
If the answer is 4, And they say at what distance will you get an antinode? Was that what they said? One antinode is equals to what? 1 all over 4 from our diagram like this, right? You say we have lambda all over 4, which is the same as 1 all over 4. Is that okay? So this lambda here, you are multiplying, we are having 1. Our lambda is what? Our lambda is what? Multiply by this. What is the answer? What is the answer? 1 times 4. Let the person approximate and meet us at the other side. Joy, was it because you used calculator? You used 88.5. You are very correct in your own end. While in our own area too, we are very correct.
1 meter. 1 meter.
Okay, let's take this question. It should be the last question. Okay, let's take this question. A vibration of frequency 60 Hz is used.
Sir,
Are you not true with this?
I'm true. You said it very fast, like
A vibration of frequency 60 Hz. All this thing be writing in short form. You are not a vibration VIB of frequency, write F or FREQ. Don't be writing everything like you're writing note to go and submit to your teacher.
Of frequency.
A vibration of frequency 60 Hz is used 60. A vibration of frequency 60 Hz is used in generating a transverse stationary wave. In generating a transverse stationary wave. Just put full stop. Stationary wave in a long thin wire. In a long thin wire.
Long steel wire.
Thin. Like the string of a guitar now is thin. A long thin, yes. From tiny you got thin. A long thin wire. Full stop. In a long thin wire. Full stop. If the average distance between successful node, if the average distance between successful node, if the average distance between successful node of the wire is 45 cm. If the average distance between successful nodes of the wire is 45 cm, find the speed. Find the speed. A vibration of frequency 60 Hz is used in generating a transverse stationary wave in a long thin wire. Full stop. If the average distance between successful node of the wire is 45 centimeter, is 45 centimeter, 45 cm. Find the speed. Find the speed. Jesus. You are wrong. Somebody is saying 5,400. No. 5,400. 27 meters per second. Who else? Give me your answer. Give me your answer before we solve. Who else? You say what? Is V equals to F lambda? But you're having node. What did you do with the node we're having? Distance between two successful nodes. Is it a wavelength? Are you sure? Distance between two successful nodes. Two successful nodes. Some persons just missed it now. All the answer you gave me are wrong. I'll not calm down. Why will you tell me to calm down? Will you tell your... So all the marker was wasting yesterday. Writing N is waste. The distance between a successful node is an harmonic. Is it a harmonic or an harmonic, whichever way you want to call it? So you're having two nodes. When you're having two nodes, it will be what? If you're having two nodes, the formula, the length is going to be what? What? Lambda over 2. Right? Your L is equal to what? Lambda over 2. Lambda is equal to what? 2L. And from the question, right? We have 445, right? Is it 45 cm we're having? You now say 2 times 45 cm divided by 100 to convert this to meter.
13.5.
54. You've arrived at the final answer now. Something like that. So we don't understand. They are using English to confuse us. The English, they say distance between two successful nodes. Eh? They say two successful nodes. This one node, this another one. If I'm to draw now, I'll be having 3. Right? Why I have one antinode here, I have another antinode here. So if they are telling you distance between two successful antinodes, they are telling you half again. Because if you turn this to face each other, it will still be one harmonic. So please, whichever way they come, we'll conquer them in the name of the Lord. These are JAMB questions we are solving. Are they not simple? Are they not simple? They are simple. They're not simple. They just want you to think.
A bit simple, a bit hard.
Eh? We should leave it in centimeter. Somebody said we should leave it in centimeter. You need to convert it to meter. The unit of wavelength is meter. So you need to convert it before you multiply it through. Let's take the last question before we move forward. We have solved enough problem. Let's take the last one. This one is still JAMB. 1980. The time they used to use calculator and pen to write JAMB. Toby, have you arrived? You got 54, right? Some person are still solving. If I say go to the house and solve, when you get to the house, JAMB. Answer is what? 13.5. How did you arrive again? Did you convert this?
Yes.
If you convert this, it will be what? 0.5. You'll be having 2 times 0.45, right? Yes. Multiply to what will you be having? It's 0.45, not 0.9. The next question. You already know what to do, right? We don't have all the time. I will not wait for the last person to be through solving before we go to the next question. You are dragging us backward.
When divided by 100, you get the 0.5.
0.9 now. 0.9 multiplied by 2.
Push.
By 2. 0.9 is not by 6.
I know graph. Put this times 2 first, give me 0.9.
I'm ready to my 0.9.
Times 60.
A man stand 1/3. Note that word. 1/3. A man stand 1/3. Yes. You can write a woman stand or a girl stand. A man stand 1/3 of the way between two walls. Like where I'm standing now, I'm standing 1/3. You divide this place into 3. I'm standing 1/3.
Yes, sir.
A man stand 1/3 of the way, not wave,
We, no we, yes.
of the way between two walls.
One of the way.
Road of the road. If you don't, if you can write road of the way between two walls. Between two walls. And clap his hand.
And clap his hand.
To praise the Lord.
And clap his hand. His hand.
Come on, clap your hand.
And clap his hand. Full stop. He hears two distinct sounds. He heard two distinct. He heard two distinct like this.
Distinct.
Distinct.
It's not distinct. It's distinct though.
There's-
Not distinct.
Sorry. Distinct.
Yes, sir.
Like this.
Yes.
I started saying double. Somebody should buy me more than milk. I don't understand cold water is. As if you are looking at this by water. Distinct echoes.
Either way, you the new ones.
Echoes or sound 1 second apart.
Echo or sound.
Two distinct sounds.
Use echo. It's still sound.
1 second apart.
1 second apart.
1 second apart.
If the speed of the sound is 230 meters per second,
Of the sound is 330 meters per second.
calculate the distance between the wall. If the speed of the sound, the
360 meters per second.
330. If the speed of the sound is 330 meters per second, calculate the distance between the walls. I'm seeing this 330. It's as if you are going to see question of 330 in your JAMB.
Amen.
Yeah.
You say amen. Why did you say amen? That's what I hear.
Some persons are still copying the question. You are not true, Abi. You have not even started. What do we do?
We solve. Which formula?
Which formula? It's in your nose.
Distance, yeah. 2D over. What is dividing by
We have something like V is equals to what?
2x.
All over what?
Over t.
Is it over T?
Yes, over here.
No.
Is there anything that can be done with this?
Yes, sir.
With your 1/3 that you are having? Note that 1/3. Very, very, very important.
Yes.
1/3.
Let's solve and see.
1/3. 1 all over 3. Toby, what do we do? 220 as a distance. Are you sure? What did you use? You know the sound is 2. If we are having 2 sounds, we are going to be having 2 times. And they say 1 second. 1 second is equal to T. 1 second is equal to T2 minus T1. Then you have the difference in the time, right? Let's just solve. Now we are having, this is the man, right? This is the wall, and the man is standing. 1, 2. We're having 3 here, right? This is 1 over 3. And this S. This is the whole distance. Right? What are we looking for? So we want to know the distance from this place, from A to B. Now we are having the whole distance to be S. Right? This is where the man is standing. 1 over 3. Okay? So S will be equals to what? 1 all over 3. Is that okay? Now, if we go further, to get this, we can say S minus 1 all over 3. Is that okay? S minus 1 over 3 is equals to what?
X over 3.
Minus X over
Minus X over 3.
Is that okay?
No, sir. No, sir. I'm lost.
We are doing arithmetic.
Yes, sir.
This is not physics.
Sir,
We have S is equals to 1 all over 3. This, right? Now, we are having the whole distance to be X. Now, we minus this 110 from the X. And if we say the answer is minus, you have found S. If you get this answer, I'll give you 1,000 as I'm standing like this. Eh? 55. It's not close. Now, watch carefully. Watch carefully. We are having minus S over 3, right? Minus 495. We got minus 495. Minus 495. How did you get minus?
we are calculating this stuff, so how will be this stuff with 1 minus?
You are very, very close. You are too close. You are too close.
Okay, sir, 495.
Give me another answer. You are very, very close. Okay? She is very, very. I can't say she's right, but she's. Okay? Now, if you are taking this, hello, if you are taking minus S, we'll be having what? We'll be having what? People don't want to talk again. Or is it that, is it the money that again? But if people are not talking again, but I expected somebody to get the answer. You said what? The S we are minusing the. We got this as the 1/3, right? We are removing it from the S again to have 2S over 3. Joe, what's the answer again? What did you say is the answer? Final answer. Come and explain for us how you got 495. That's very correct.
Very correct.
And I'll give you 1,000. I'll give you, don't worry. I have the 1,000, don't worry. I'll give you. Come and solve. Come and solve for us. Arrange it. I'll come and solve for us. Your answer is what? Your answer is what? 165. The answer is, you say, the answer is 495. Don't worry, come and try. Let's see what he did. Stop making noise. 49.5. No exponential. No exponential. I'm having 49, 495. That's what I'm having.
No.
So my answer is 495. Idiot.
So boy cannot get this.
Try. Let's see what. Let's see what.
Our teacher.
Let's see what you're doing. Please watch. Please watch. Let's see what she did.
This is what I did. This is what I did. So sir, I saw in my notes. I saw this X.
Why am I taking money for like?
So that we like. So we already established the fact that X minus X prime. I don't know what we established that. Minus X over 3. I hope we don't have got minus X.
That was what I was doing the other time. I did it. Yes. Then no. I will explain for you if you don't know.
We now have two values for X1 and X2.
For me, I got minus 1.
And then
Why did you got? How do you get minus 1? 2 echo is 1 second. Right? Okay, is it because you want to cancel down minus? Okay, continue. Continue.
So I'm supposed to do 1 now. So first to okay, then onwards.
therefore you don't come to
So just like here now. Please calculate for me. Here is 165. Like here is 0.5, 0.5. So what's the minus 165? Then I don't know where this simple minus came from, but it just came here. Then I minus. I don't know where it came
don't know where
Clap for her. She tried very, very, very well. Go and sit down. I'll give you your money.
You have your 500.
No, she made a very, very good attempt.
Wow.
a very, very good attempt. Wow, I love what I hear.
No, I'm just surprised. I'm just surprised. Take a 1,000 naira. So she really, really did well. I was amazed of. She was very fast.
There's another way to
Okay, come and solve it for us another way. And we'll get the same answer.
This is not here. Oh, sir, I know what you're about.
Hey, son,
I know what you're saying.
your
I know what you're to do.
B is equal to 2x over T. Abi? Okay. So from here, remember the size one said, Abi?
Yes.
You minus x over T for x, you have 2x over T. Abi?
I don't grab.
That's 2x over T.
I know X over.
This 2x over T here, now your distance. Same distance.
Distance.
Normal. So, and your speed is 330. Now 330 is equal to 2 times. You know this one is now your x.
You
You don't
repeat it.
understand?
You grab it.
Times. You don't understand?
He's very, very correct. What he's doing is very right.
Yes, sir.
Please what?
Over T. Calm down now. Then the time is 1 second.
Yes.
So it does not matter. We don't.
Yeah, go. Wisdom.
4x over
TV.
this 990 equals to 4x. To divide it, you have 275. Wait, now,
The Coco come. You don't mess the whole thing up. You don't mess the that two is supposed to come
Stop
anyway.
up, let me talk.
We have to talk. You don't just 275.
People are coming to another way to solve, another way to solve. Don't pass through the window.
You know it's 2 words. Multiply by 2. No, that you might be seeing the 2 words now, so this time is 2 words.
Okay, wisdom. Laugh. Answer them. I know what to solve
Hello.
I know the shortcut.
Okay, you know the shortcut.
The shortcut one. The shortcut
Hello. Hello. Hello.
Nice.
He did very, very well. Eh? What is another method? We have plenty methods to get to the final answer.
Yes, to the answer.
Is it wuru wuru?
Yes,
We don't want wuru wuru.
that's what we learn. That's what we learn from here. Yes.
I did not teach you wuru wuru.
I'm not the one. That's good.
Permit me to wipe this. This thing that you saw. Okay. Don't worry, I will explain it. I will do it. Don't worry. Is it the minus that is a challenge? How many? Do you understand the question very well? Come and attempt it. Be fast, be fast. We don't have all the time. Let me read the question for you. The man start 1/3 of the way between two words. Between two words. And he clap his hand and he hears an echo 1 second apart. Okay. The speed of the distance is 330 ms. Calculate the distance between the words.
V equals 2x/t. Okay.
I like what I see, but
330 equals to 2x over 2. That is 1. Yes. Notice 1. Then that is 2x equals to 330. X equals to 165. So you know 1x is 165. So 1 over x over 3. That is 165 over x over 165 over 3. That is x equals to 165.
Times 3 over
495.
Thank you very much. Let me understand the question very well. Our V is what? 350 is equals to 2x all over what? 1, right? And then from there you say we have, so we have 330, right? Is equals to 2s. Okay. Then you'll be having, how do we get our s? Eh? S is equals to 330 over 2. You not get 195. You tried, but we will not get 195. We are looking for 495.
Okay, now this x1. To get x2, you do x over 3 equals to x2. That is x1. So x, that is x1 equals to 165 over x over 3. That is equals to multiply. That is x equals to 495.
Do you understand what you did?
Yes,
You say this is S1, right? And you now come here to say x all over 3 is equals to what? X1. Is that okay? Then we already have our S1. When I say x all over 3 is equals to 165. Right? You cross multiply, you be having s is equals to 165 multiplied by 3 What's the answer?
495. Methods now. We have to
Hello. Hello. I am very, very impressed. You are reading. You are reading. You are very. I am very, very impressed. And this is even a shorter. This is a shorter way. This is a shorter way as compared to what I want to tell you now, because so many persons will be confused. Okay.
How did you get that 165?
165. When he was finding S1. When he was finding S1. You understand? Say V is equals to 2S all over T. It's from the formula.
That's the formula. It's a formula.
Yes. So from that formula now, we now have, he decided to solve for the first S to get the second one now. You now use that method.
If somebody else will understand.
Are you copying? Oh, yeah, copy. Let me solve my own. Mine is long method.
We already have plenty methods.
Just know the formula. No, it's not lie. Like what he did now is very, very correct. What he did now is very, very, very correct. You understand? All you need to do, understand the formula, know how to manipulate your way around it.
Yeah.
So far, your answer can be proven. That's all we need. All of them are wrong.
Yes, they are wrong. You know why? They forget
They are what?
you know what I want to say? They are unique. They are unique, so all of them are wrong.
I will help them with their unit. Can I solve my own now? Can I wipe this?
You may not understand, but I use my own to answer the question. Everybody's pretty aggressive. What temper of this movement and I surprised me. How you find such? Wow, I'm impressed.
We'll be having, just like I said, we have 1/3 here. You said what? You said what? Now be having, our first S will be having S. Are we together? I'll just be solving. Since people, if you are making noise. S minus S all over 3 will be equals to what? 2S all over 3. Can we move forward? Yes, this is my own formula.
These 5 methods you have now. If you fail that,
Now, let's say our T1 is equal to
you live with the chicken.
X all over 3 and T2 will be equal to 2S over 3. This one is long method.
Very long.
Is that okay? We understand that his method as well. I will have T1 now be equals to what? 2V all over, sorry, 2x all over what? Who is saying 3V? So here now what are we going to have? We're going to be having what? 2 is equals to 2. Our value of S is going to be equal to what? The value of S will be equal to what? For T1.
X over 3.
All over. Is that okay? This one is a white student. Then we having your T2 be equal to what? 2S all over what? V, right? Your S is equal to what? 2S over 3. Is that okay? Who is saying no? Where are you? Who said no? You? Where are you confused? Is it here? Here? This is the formula. T is equal to 2V all over. We are having, they say first time and second time. The sound was heard 2 times. Like I say, hello, the first echo arrived, the second echo arrived, right? Then I say T1 minus T2 minus T1. Since the difference between the time is equals to 1.
Then sir, why did you put T1 there? That's
Don't worry.
confusing me.
We want to get the 2 different times.
Like, no, 2 different times. We're looking for distance, no
Yes,
time.
don't worry, we are getting there.
You said look for the time.
How will you look for time when we don't?
Watch and look carefully. Now we are having T1 to be equal to this. We are having T2 to be. Our V is what? 330. Is that okay? Now we're going to subtract T1 from T2. Is that okay? Where T2 minus T1 is equal to what? 1. Right? So I can say, I don't want to wipe anything. 1 is equal to, are you watching? 2 times x all over 3, all of 2 times 2x all over 3 all over what? 330 minus 2 times x all over what? 3 all over. It is also equal to what? This is also equal to be having 330. What are we going to be having here? What are we going to be having here? Now from here we're going to be having 4x all over 3 minus 2x all over 3. Who is saying how? Where?
Cross multiply, so you grab 2 times like 2 times 4.
Toby, do you understand to this part? Okay, from there, we'll be having what? 4x. Remember, we are still having our 1 equal to 4x minus 2x all over what? All over 3 over 330. Is that okay? You take the SM of this and this. You have 4s minus this. Is that okay? I'll be having what? 2s over 3. Let's remove this. Is that okay? Let's have this multiplied by this. Let it go. We're having 330 is equals to 4s minus 2 all over 3. Is that okay? Cross multiply. 990 divided by 3 is what? 990 divided by 2 is what? 495, right? That's how we arrive. 330 multiplied by 3. We having 990 equals to 2s. So you divide through by 2, you'll be having your s as 495. But I like that his method. Hello. So I like that his method. It's very, very short too. What is shorter? Short circuit. It's smart. But even as you are smart, if you can prove your smartness, like this is the proof. If a lawyer is telling you that this is black, he will give you 1,000 reasons. And after listening to the reason, you believe that it is black. So if you can prove it, then you are correct. If you can prove it mathematically, then you are correct. We have dwelt so much on this mountain. Let's get an introduction to light wave. Can I wipe this?
Everybody on a phone now. Everybody wants to understand. Everybody wants to understand. So it's
Can we move forward?
you want to move for a street? Yeah, the whole violence gang. You want me to for a street? We don't need break.
Can I wipe?
Yes, sir.
What's the time? Is it time?
Hey, line 42.
That time is 10:30. See what we can say for you.
Abba boy.
Abba boy, this class. That was your next night. You might be follow. You will pass me. And now, obviously, was named that way. Like, I cannot like.
Oh my, all is good.
The outside.
Are you through with writing? Now we talk about reflection of light wave. When you are hearing the word reflection, Now, when you hear the word reflection, it means when something goes and is being thrown back. When you are flashing a mirror and the ray of light that enters the mirror is coming back to you, it's reflection. Is that okay? Under light, I think it's under light, right? We have opaque object, we have transparent object, and we have translucent. Is that okay? Opaque, the light cannot pass through. Translucent, what happened? Then transparent.
Translucent is like when you put oil on sun.
Transparent is when the light can pass. When it comes to opaque and transparent.
Opaque means light can go through, but translucent means a little of light can go through, like when you put oil on
What's the difference between transparent and translucent?
Transparent, light goes through it.
In transparent, light can go.
Not all the lights can go. Like if I'm flashing a paper, right? It will show that a little will pass, but it's okay. Now let's look at the reflection of light wave on a plane surface. If this were to be a plane surface AB and a light ray is being incidented at L, are we together? A light ray is being incidented at L. When this ray falls on the surfaces, it's going to be reflected at an angle. Is that okay? Now, this ray has been incidented on this plane surface is at a normal O. And the major reason why we are having this normal is for us to get the difference between the reflected ray and the incident ray. And mind you, the normal is always having an angle 90 with the plane surface. Is that okay? So when this ray comes in and it meets the plane surface, it's being reflected. And the reflected ray is this ray that goes to M. Now, when a ray is being incidented on a plane surface and this ray is constant, it's going to bring out a reflected, we're going to have a reflected ray, and the angle of the incident will be equal to the angle of the refracted if the ray is constant. Is that okay? That is to say, I is equals to R. So this angle LNO will be equals to ONM. Is that okay? Now, theta now is the angle that is formed between the plane surface and the incident ray. Is that okay? If I'm having theta here, we'll also be having theta here. But note, angle of deviation is not NMB. Angle of deviation is not NMB. If I'm having P here, the angle of deviation covers from this angle to this particular end. Is that okay? Is that okay? Do you have any question on the explanation of this? For those of you that are doing WAEC and you are doing practicals in your WAEC, take note of this thing. It is very, very important. It is very, very, very important. You need it. Is that okay? Because we are not allowed. Or are they doing practical for WAEC students here? It's okay. So right. Number one is what I explained. I just want to write. Is there any need for that?
Yes, sir.
LN is I. LN.
Alright, so Muna, right?
LN is I. Do you know what? You know what I means, right? I is the incident ray. And ON is the normal. The angle of, write like this. If I say angle, just write this. If I say angle, just write this. Is that okay? The angle of I is equals to R.
R.
Angle I is equals to and it's vice versa. If I is equals to R, then R can be equals to I. Is that okay? Then we have theta should be as. They can label A, B, C, D, and they ask you, where is the glancing angle? Where is the glancing angle in this diagram? LN. LN is not an angle, LN is a ray. So if you are giving me an angle, it should be LNO, ONM, LNA, either. So what is the glancing angle? ONM. This is the refracted angle. Reflected, sorry. Theta is the glancing angle. Right. Angle theta is the glancing angle. Angle theta is the glancing angle. It's the same as M and B. It's the same as M and B. M and B. Is it not the same? Angle theta is the glancing angle. It's the same as M and B. Don't mind my diagram. All this angle, they are supposed to be accurate, but this is freehand drawing. Is that okay? So if I'm to use my protractor and my is there compass? Compass is not needed in this.
Your pencil.
Okay. Angle of deviation is equals to 180 minus angle of deviation is equals to 180 minus I plus R. So are you confused with this diagram? You are trying to understand it. Okay. Angle of deviation is equals to 180 minus I plus R. Eh? Please don't distract us if you are not part of the class. Excuse us. Please. Somebody is playing music. Please, whoever is playing music, please. We don't need the sound. Thank you.
We are done with sound wave.
We are done with sound wave. We don't need jam boss. Where were you when we were doing sound wave? Do you understand what I say? Say the angle of deviation is equal to what? 180 minus
I plus R.
Like this. Do you understand? Now, look at this very carefully. Are you seeing? Are you seeing the board?
Yeah.
This is an angle from L to D, right? Let's assume it's 180. Do you understand what I'm saying? If L to D is 180, right?
Yes.
Straight line.
Yes.
And you remove I plus R, you'll be having this remaining one. as angle D. Is that okay? Somebody confused? WAEC student, you must understand this thing more. WAEC student, you must understand this thing more. I said the angle of deviation, if LP or LD is 180 and you remove I and R, you'll be having this M and B as your angle of deviation.
Is it P or D?
Either one, any one you want to use. They are just they are just number alphabet that we're using to connote it. N M N.
Like, what do you think?
Is anybody having any question as regard to this? Do you understand it? That's about, do you understand it? Eh? Not really. Are you writing WAEC? Where we started from, I said this is the incident ray, L. Are you seeing it? When it lands on this surface, it's being reflected at M. So the angle the incident is forming with the normal is the same as the angle the reflected is forming with the normal. Where O is the normal. Is that okay? So we now say this angle I is supposed to angle R. If L is constant, do you understand? If you don't understand, meet me later. I'll explain for you more. Yes, she's my neighbor. I'll not tell you. I'll not tell you.
Okay, back to your neighbor.
I'll not tell you.
If it's your neighbor, then I will know your house.
I don't understand.
Okay.
Right. Note, if you are moving object from if you are moving object away, if you are moving object away, is it time? It's remaining 4 minutes. Let me use my time.
Yes, sir. Thank you, sir. Right on.
You are owing me 10 minutes. I want to collect it today. You are owing me. I gave you for 10 minutes. Right. If you are moving object away, object away from a pinhole camera or from a camera, whichever one. Camera or from a camera. You add the distance. Be listening to this simple thing and say no. Because when you are being given a problem now, this is what will assist you. You add the distance value. Then when bringing it closer, when bringing it closer, you subtract the value. That's magnification. That's magnification.
So please come again.
That's magnification.
The formula for a pinhole camera magnification, M is equal to image height all over object height. I know you've done all these things. Which is also equal to image distance from the camera all over object distance from the camera. Now, image formed by an inclined mirror. Image formed by an inclined mirror. Very soon I'll tell you I've come to the end of light.
Image.
Formed by an inclined mirror.
So you have 1 minute more. Did I see 1 hour? Sorry, I didn't want to divided by 6.
When image formed by an inclined mirror. From the camera, yes. Then object distance from the camera. People are still there behind.
Image, you say
When two mirrors are inclined at an angle theta to each other. When two mirrors are inclined at an angle theta to each other.
are inclined at
an angle theta to each other, the number n of the image from when two mirrors are inclined at an angle theta to each other, the number n, put that n in bracket, of the image form is given by n is equals to
the number n to the image is equal to n.
N is equals to 360 all over theta minus 1. So if you are having the angle, if you are being inclined at 30, you have your angle at 30. You are being inclined at 60, 45, 25, whichever angle. That's what is going to be determined. That's what will determine the kind of image that will be formed. At times, you see yourself when you're in the barber salon, you'll be seeing your image. It's going far. That is plenty, you cannot even count it. You want to know the number of the image that is formed, even without you counting it. It's for you to know the angle at which those mirrors are inclined. Then after knowing the angle, if you start, you have your n, number of image, is equal to what? 360 all over, let's assume it's 30, minus 1. You have the number of image that will be formed. Let's call it a day. We'll continue from here.
After the break.
After the break.